Hey there, it's Greg with Thriving on Tech again. And today I wanted to tell everyone about an opportunity to fight diseases such as cancer, neurological diseases, even COVID, without having to donate money, participate in a walkathon or bikeathon. It's an opportunity for really anybody with a computer to participate in. So the program that I wanted to talk to you about, it's called Folding at Home. It's been around for about 20 years, and it essentially is a program that allows scientists to simulate the folding of proteins. Now, before I get into the specific details of the program, I think it's important that we talk about what a protein is. So proteins are the basic building blocks in our bodies. They make up teeth, bone, muscle, hair, really just about everything. And they're essential for carrying out really any process that our body does in order to survive. So contracting muscles, going to the bathroom, all those types of activities. In order for these activities to take place, proteins quote unquote fold or self-assemble. This self-assembly process we don't know much about because proteins are incredibly small. We know that they self-assemble, but aside from that, we don't really know much about it. The problem is that proteins are incredibly small. To give you an idea about how small they are, a single cell can have millions of proteins. So as you can imagine, there's not a lot of equipment that we have to monitor these simulations right now without some really high-powered computing, which is inordinately expensive. So that's where this program comes in. Basically, it started at Stanford University, and what they did is they created a distributed computing platform that allows users, or basically anybody with a PC, Mac or Linux-based system, to download a client and start assisting and donating their unused computing resources to aid in the simulation of proteins to help doctors observe these simulations for further research to help fight these diseases. So, how does this protein folding relate to diseases like cancer, neurological diseases like Alzheimer's, Huntington's, and many more? So when this protein folding occurs perfectly, everything works fine, and we won't notice it in our bodies because everything is working. But when protein doesn't fold correctly, that's when these diseases occur. And that's what the scientists are trying to look at. They're trying to look at when these simulations and proteins misfold, that's where they're trying to identify, and that's the starting point to identifying therapeutic opportunities to treat these diseases. Think of this as really the nuts and bolts before that you get into the lab and start performing experiments and then transitioning to drugs and transitioning to the actual drug and giving it to the patient. This comes way before that. So now that I've told you a little bit about what this program is, I would now like to show you a demo of what it looks like, because I've got the client installed on my computer that I built a few months ago, and I can show you just how this simulation works, what it looks like on your computer, and how it uses your computer resources to perform the simulations. So I'm going to go ahead and present my desktop here. Here's the website for Folding at Home. Currently, they have thrown all of the resources behind COVID-19, but they will be switching back over to the cancer and other neurological diseases over in the next couple of months. But they have made a lot of progress, really in all aspects of their research. So this is their homepage. I will go ahead and provide a link here in the description below so you can go ahead and do this. But right now, we're going to go ahead and start folding. So I'm going to pull up the client here that I already have installed. And it opens up in a web browser. And you can see here, I'm folding as Thriving on Tech. So you name yourself, you create a username when you install the client. I use just Thriving on Tech just because it's the name of the YouTube channel. You can join a team, but you don't have to. They do occasionally have contests for the most points because you do receive points based on how many proteins you fold and how much work your computer does. So that is kind of a side benefit of participating in something like this. And so you can see, but it taxes both the CPU and the GPU. So right now, it's currently turned off. So we have the option to start folding whenever we want to. You also have the option to fold while you're working, which is obviously if you have a powerful computer, your computer can probably handle that. So it's going to be handling obviously the work you're doing plus the folding, or you can select it so it'll only fold when idle. So we'll go ahead and we'll start folding here in just a second, but I do want to show you something before we start, just to give you an idea of how much usage this application uses when it's working. So what I've pulled up here is just a dashboard I have to track utilization for my graphics card and CPU, as well as temperatures, voltages. Really, it's a diagnostic tracking device for the computer. You can see here our GPU usage is at just 7% and 9% now, hovering around that there, and that our CPU usage is hovering around 2% to 5%. That's probably pretty accurate considering we're really not doing anything right now, other than just opening up a browser and just kind of searching around and browsing. Once we start folding, we should see that increase. So I went ahead and I clicked the folding, and we should see things start to crank up here. So we've got the CPU working now, the GPU is working, and as you can see, our GPU usage, or our CPU usage has now increased to 95%, and our GPU usage should start to slowly climb as well. There we go, we're at 98%, 99% now. And you can see our temperatures are starting to slowly climb as well on our CPU. Go ahead and get this out of the way for now. So you can see on our Folding at Home dashboard, this is the progress we have on this current work package that they sent us, or work unit that they call it. So the CPU is 65% done, the GPU is 2.3% done. It gives you an estimate to completion. You can stop folding whenever, and it'll pick up right where you left off whenever you start again. And then the really interesting thing, if you do want to really learn about what your computer is helping with, you can actually dig deeper and see what the actual project is that your computer is working on. So for example, my GPU is working on a project for the SARS-CoV-2 receptor. And I won't read everything with it, but you can read the description, and then you can even dig deeper and see the researcher and what hospital or university is hosting this research project. So a lot of detail that you have to dig deep and really learn about what is happening, what your computer is doing, how it's contributing to the research, which I think is really cool. Really cool as somebody who's interested in tech, as well as somebody who's has a very important interest in cancer research and medical research. So we're going to go ahead and stop folding for now. And we'll go ahead and stop. So that's a little look about how Folding at Home would work on your computer, how it would use your computer's resources, and how you could participate in Folding at Home if you wish. Some pretty incredible statistics about this distributed computing platform. They currently are, as I said in the demo, they're currently pooling their resources for COVID-19 because that's, as we all know, it's been the focus of 2020, and starting in 2021, it's going to be the focus as well. Eventually, they will, transition back to the research for cancer and many of the other diseases. But COVID-19 has helped this program. When COVID-19 broke, many people signed up for this program. And currently, they're performing their total computing power of all the users involved in this folding at home. They have a total computing power of 2.5 hexaflops. Let's think about that for a moment. A hexaflop is made up of 1 million teraflops. And now let's think about what a teraflop is. The new Xbox Series X currently has 12 teraflops of computing power. So I'll let you go ahead and do the math of what, how many Xbox Series X's that would equal that they're using at folding at home. But that gives you an idea of just how much power is behind this distributed computing platform and how much power is being put towards medical research. It's currently more powerful than the top 500 supercomputers in the world. So that's more powerful than what IBM has, what NVIDIA has, what AMD has, what these other research institutions have. It's basically the most powerful supercomputer we've ever seen created. So the goal is to keep the power going, keep people signing up for this thing, because as patients, myself personally, as a stage 4 lung cancer patient, we depend on new drugs to come out because we're constantly jumping from one drug to another in order to continue living. So as you can see, as a cancer patient, I have a concerted interest in this. So I hope you enjoyed this video. If you did, please press like, and hopefully you can subscribe as well. And that does it for today, and I will see you in the next video.